And we are on the third method, which is the elimination. So we had graphing method first, which is probably the most annoying. Just because you have to draw the graph, so it takes a lot of room. You have to do it accurately, otherwise it doesn't intersect at a nice point. And sometimes the graphing one doesn't intersect at a nice point, in which case it's not really useful. So then we learned the substitution method, where you got one variable. Remember, we tried to figure out which one would be the easiest to get by itself. And once it was the easiest to get by itself, then we substituted into the other equation. And this is the elimination method. So I'm going to just show you an example, and then we're going to talk about how to solve it. You don't have to write this example down, but let's say you have two equations and you want to find out where they intersect. So I'm going to do one equation there, and then another equation, and I'll give you a really easy one to start. So with the elimination method, what we do is we write the two equations so that we have our x's in the same column, our y's in the same column, and our numbers in the same column. It's really important that everything lines up. And then instead of substituting, we just take the equation and say, what would happen if we added them together or subtracted them? And the idea is we want this to happen. So you see right here, I have a 2x and I have a minus 2x. If I added those together, they would cancel out. And so what I do is I take the whole equation and I add my x's, I'm going to get 0 here. If I add my y's, 3y plus 2y, that would give me plus 5y. I still have my equal sign, and if I add my numbers together, I get 10. And the idea of this method is if we can write the two equations on top of each other, columns lining up with the same things, so something gets eliminated when we add it. Now this is an easy thing to solve. How would I get y by itself? I divide both sides by 5, and I would get y is equal to 2. Then just like substitution, once you've figured out one variable, we can solve the other variable either by, and again, we're going to talk about two equations. You can plug y equals 2 either into equation 1 or into equation 2. If I plug it into equation 1, I have 2x plus 3, and I already figured out y was equal to 2 is equal to 8. That would give me 2x plus 6 equals 8. Get my like terms together, so I'm going to subtract 6 on both sides. And since they're x and y, we can write our solution as a coordinate. This is where, on a graph, these two would have intersected. So now that we've seen an example, let's go back and look at what the steps say. Step 1. Simplify the equations if necessary and write them one above the other. It is helpful if the equations are in this form, something times x plus something times y equals c. And the equation I gave you, that part was easy because it was already given in that form. I already had them lined up, okay? Now, sometimes you have to change an equation because they don't, like I wrote it so that they were already a 2 and a 2. But sometimes equation 2 might have started like this. equations 2 might have started as negative x plus y equals 1. Can you see that the one that I wrote is just this equation all multiplied by 2? And the goal is to get something to be the same with one thing positive, one thing negative, so you can add them to eliminate. You can also have them exactly the same and subtract to eliminate, but I find that students, when you subtract, you make more mental math errors. So generally, I always try to make one positive and one negative so I can add to eliminate, and then we end up making a little bit less mental math errors. But you can also subtract to eliminate. So that's step 2. Sometimes you have to multiply one or even both of the equations to get things so that they can eliminate. Step 3, add the equations to eliminate one of the variables. And then step 4, we found once we eliminated and we're able to solve for y equals 2, then step 4 says you can easily plug that back in and now solve for x, and then you can write your answer as an ordered pair and a solution method. This is the elimination method. I think it's a very, very fun method because you get rid of a variable and you take a complicated equation and make it simpler right away. So here's our first example. We're going to solve this with the elimination method. I hope you can see that it would be really easy also to use the substitution method. You could get either x or y easily by itself and substitute into the other one. But when I look at this, x's are in the column, y's are in their column, the numbers are in their column. And can you see that the coefficients of y are already the same but opposite signs? That's our goal, to have either in front of the x's or in front of the y's something with the same number in front but one positive and one negative. Because now, if I add these two equations together and add my like terms, x plus x will be 2x. And y plus a negative y will be 0, and 7 plus 5 is 12, and we eliminated the y. And once you've eliminated the y, now this is just a grade 9 question. How hard is it to solve for x, to get x by itself? All I'd have to do is divide both sides by 2, and I get x equals 6. And now you have a choice. You could choose either equation 1 or equation 2 to solve for y, so you plug in 6 for x, and to get y by itself, I'd have to subtract 6 to the other side. So on the graph, these two lines would intersect at 6, negative 1. Comparing this to the graphing strategy, if you use the graphing strategy, you would have to change both of these to y equals mx plus b. Then have a nice graph, label your y-intercept, use your slope to draw everything, and then find where they intersect. This is a lot faster. And this will work even if they don't intersect at nice places. But sometimes with the elimination strategy, things line up. So right now I've got my x's on top of each other, I got the y's on top of each other. The numbers are on top of each other. I could keep them there, or I could move them to the other side. It's not necessary that the numbers, you could have it like this. I could move the 8 over to the other side, and I could move the 7 over to the other side. But as long as things line up in columns, you can use the elimination strategy. The problem right now is if I add them, neither the x's or the y's would eliminate with each other. I need to get the coefficient, which is the number in front, to be the same, and for one to be positive and one to be negative is what I like so that I can add them together. And you can choose to eliminate x or to eliminate y. You've got some choice here. Both will work. It's just a matter of which one you want to eliminate. So let's say I decide to eliminate the x's. I have to think, what could I multiply this one by? And then I want to multiply this one by something so that the number in front is the same, but one's positive and one's negative. So we're going to get into sort of like that lowest common multiple idea that you did way back in the factoring unit. That seems like a long time ago already. It was like last year. Okay? Okay. So, what multiple would be both 2 and 3? What's the smallest one? 6. So, in equation 1, I want to multiply everything by 3. In equation 2, I want to multiply to get 6, but I want 1 to be negative, so I'm going to multiply everything by negative 2. A little bit of mental math then. This becomes 6x. 3 times 3y will be 9y. And 3 times 8 will be 24. Equation number 2. Maybe I'll keep labeling. Equation number 2, if I multiply by negative 2, is negative 6x. Negative 2 times positive 5 will be plus 10y. And negative 2 times 7, negative 7 will be positive 14. And now we are ready to eliminate. Sorry, the elimination technique also is just way more fun to say. So when I add these together, sure enough, my negative 6x and plus 6x gets added to be nothing. 9y plus 10y, okay, 19 is, I don't know, 19 seems like a scary number to me. I feel like maybe we'll have fractions here, and if we had fractions, it would be bad. I'm hopeful, though. But if I add 24 and 14, I get 38. Does 38 divide nicely by 19? Yes. We are not left with a scary fraction. Y is just equal to 2. Y is equal to 2. Now we have to find x. And you can plug that y equals 2 either into equation 1 or into an equation 2. And I've been labeling the 1's and the 2's because I want you to see that mathematically, algebraically, all of those equation 1's are exactly the same, just with different numbers. We just rearranged an equation. Mathematics does this all of the time. It says this is equal to this, like 2 plus 3. If your friend said, oh, I didn't get that, I got something different, I got 5. You're like, oh, I got 2 plus 3. One of us must have made a mistake. Well, no, those are the same thing, just written in different ways. Math does that a lot. So all of these equation 1's are the same. All of those equation 2's are the same. So I need to plug y equals 2 into an equation. So if I pick equation 1, and I pick the very first one, then I would have 2x plus 3, and I've already figured out y is 2, minus 8 equals 0. So that gives me 2x plus 6 minus 8 equals 0. These are like terms. That'll be minus 2. If I'm solving for x, I need to get the x by itself. So I'll move the 2 over to the other side. Then I can divide both sides by 2. And I get x equals 1. So my solution as a point, my x coordinate would be 1. My y coordinate is 2. What's really nice about the elimination method is we solved this, and you didn't have to work with any fractions. Like, I love fractions, but fractions, I say, don't make the question harder, they just tend to make it longer. Okay? You should be good at your fraction skills right now. That fractions shouldn't make a question harder, but it just takes more time because you got to go through all your fraction rules and solve it. If we took this same one and we used the graphing method, you'd have to get y equals mx plus b for both of them, and your slope would be a fraction. If you used the substitution method, you would have to choose either the x or the y to get by themselves, and you would have a fraction with that. Here in the elimination method, we didn't have any fractions. The only time that it's possible that we could have had a fraction is possibly in the end, your answer might have been a fraction. Then when you substitute in, you'd have to work with that and work with that fraction. Okay, I want you to try this one on your own. I'll pause the video here. How you did on this one. Again, I'm going to label this is my equation 1, this is my equation 2. And I'm going to start by choosing to eliminate the x's. Usually when you're deciding what to eliminate, you like to look at numbers that are smaller, because it'll just mean when you multiply, your n numbers will be smaller. And so I looked at my y's and saw 7y and 9y. So I thought, oh, I can, multiplying the x's is going to be a little bit smaller. And I'm going to multiply 1 by 2 and 1 by -5, so I get the numbers in front. I'm going to have 10x plus 14y equals -30. That's multiplying that by 2. And take your time when you're multiplying, because it's not hard. And in mathematics, whenever you do something that's not very hard, you have a tendency to have your brain think ahead to the next thing, and it's very easy to make a mental math error when you're thinking ahead. So take your time, make sure your negative signs are right, double check as you go. And when we add these equations, this will be 0, this is a -31y. You could just write subtract 31y if you wanted. And when I divide both sides by -31, I just get y is equal to 0. So I can choose to plug that into equation 1 or equation 2. I'm going to choose equation 2 because the numbers are smaller. 2x plus 9 times 0 equals -6. And then divide both sides by 2, and x is equal to -3. So my solution, my x coordinate is -3, my y coordinate is 0. I'm going to scroll up and do the same thing again. But I'm going to show you, had you decided to eliminate the y's, we should get the same answer. So here's equation 1 and equation 2. Still equation 1, still equation 2. Over here, this is still equation 1, this is still equation 2. And this time, I'm going to multiply this equation by 9 and this equation by -7. So you can probably see why eliminating the x's was better, just because your numbers were smaller. But 9 times 5 is 45x plus 63y equals -135. Yeah, the numbers are really not as nice. And multiplying this by 7, I would get -14x minus 63y equals +42. And I add them together, and I'm going to get 31 x's plus 0, again, this is equation 1, this is equation 2, equals, and this is 93. And dividing both sides by 31 gives me x is equal to -3. Now I can take that and plug it into equation 1 or equation 2. I'll try equation 1 this time. So I would have 5 times a -3 plus 7y equals -15. -15 plus 7y equals -15. Put my like terms together, so I'll get the 7y by itself, add 15 to both sides, giving me 0. Divide by 7, and y is equal to 0. So we get the exact same solution. But just depending on the numbers, we might say, oh, the first one seemed a lot easier, just because my numbers didn't get as big. Like getting up to that 135, that pushed my mental math skills, so maybe I would like to choose to eliminate things that are smaller. Equation 1, equation 2. Now, when you're given the option that just says solve, and you're allowed to use any technique, you can choose the graphing technique, the substitution technique, or the elimination technique. I can tell you moving forward, students like the elimination and substitution techniques better because they always work, and they also seem to be a little, take up less space, and you don't have to, like graphing solution, you have to be very accurate when you graph. So they just seem to work better. And when you look at an equation, you have to decide which one you think is going to be the easiest for you moving forward. And I think I like this one because I think both the substitution technique and the elimination technique are both equal. Like it would be really easy to get a variable by itself. Can you see that? Really easy to get p by itself, or really easy even to get q by itself. So the substitution method here would work really nicely. We're in the elimination section, so I'm going to show you things that I would do with this one to make my life easier. Okay? Again, fractions don't make a question harder. They just make it longer and a little bit more tiresome. So one of the things you can do is you can get rid of fractions. So I'm going to take this equation and I'm going to multiply it by 2, because that would get rid of the fractions. And I'm going to take this equation and I'm going to multiply it by 3. And I'm going to see what my new equation 1 would be and my new equation 2 would be. I multiply by 2. P over 2 just becomes P plus 2Q equals -8. That's the exact same equation, but without fractions. Same thing when I multiply by 3, I'm now going to get 3P minus 2Q equals 24. And now I feel really lucky because I wasn't expecting this to happen. But look, for elimination, can you see that the Q's can eliminate already? We've got a +2 in front of the one Q and a -2 in front of the other Q. I thought I would have to do more work. My first plan was just get rid of my fractions and then see if I would have to multiply again to set up my elimination. But things worked out really nicely because now I can add P plus 3P. That'll give me 4P. And 2Q minus 2Q will be 0. And 24 and -8 together will give me +16. Divide both sides by 4, and I get P is equal to 4. And now I have to solve for Q. I could use any of my equations. So some people would be like, I want to use equation 1, and I want to use the equation without any fractions. So perfectly fine, we could plug it in. P is 4 plus 2Q equals -8. could have also plugged it into this equation one. Get my like terms together, so I'm going to have to subtract 4 on both sides, negative 12. And since we don't have x's and y's, we can just write our solution as what p was and what q was. And again, just like before, if you want to, you can always check. You can take this and check your original equations. If I plug in 4 for p, this would be 2. 2 plus negative 6. Is 2 plus negative 6 equal to negative 4? Yes, I know that that equation worked with the numbers I got. Try it with the next equation. If q is negative 6, okay, and p is, this will be 4 minus negative 12 over 3 is negative 4. So I would have 4 minus a negative 4, which is 4 plus 4. Does that equal 8? Yes. Now I did all that checking and mental math in my head. Sometimes you like to take out a piece of scrap paper to check your mental math. Okay? The more practice you get, the quicker you'll be able to say, I can do more of this in my head to check. Sometimes you're doing it in your head and you get lost. Does that ever happen with mental math? You're like, oh my goodness, I don't remember the first part of this equation because there was too much mental math. Then it makes sense to take out a piece of scrap paper and check it. But when you check your first and your second equations, your original ones, and your solutions work for both of them, then you know that you're right. And this is a very powerful unit that way, because you can already know when you finish a question whether you're right or whether you're wrong. And if you're wrong, it's telling you, okay, maybe I need to check over things again and try it again to see if I can get the right answer. Okay, at the bottom of the page, there is some homework. We basically have, you know what we're going to do is we're going to skip ahead a little bit. We can end the video here.